So for my project I drew this schematic and I wanted to use a pulley and a sand wheel and make it flip a seesaw so the figurine could go through the hoop. And to do this I was planning on using my brother's toys, so I got them all down, surrounded myself with them. And I opened them all up and we hadn't used them in so long that I was missing the gears from the marble run I was going to use. I was missing the heavy steel ball for mousetrap that I was going to use. So I looked for other balls, couldn't find them, they weren't heavy enough. And the only toy I have right now that I can actually use is my erector set, so looks like I'm going to have to improvise. Alright, currently I'm working on the seesaw mechanism and I've already finished the base. And I'm working on the actual mechanism itself. Shouldn't be too bad. So right now I'm going to be working on the sand wheel. I was hoping to use one of my brother's toys, but that's broken, and since it's raining outside, the sand might not work, so we're adapting it to be a water wheel as well. So I took an ABS pipe, cut off the base to shorten it, and cut 2 slots on the side with a saw. So I've taken a round piece of wood and cut little slots in it, and that's where I'll affix the cedarwood shims to make the fins of the paddle wheel. After I've fixed the position, I'll drill holes on the side of the ABS pipe to put a pulley. And originally I wanted to build an elevator system, but I realized that wouldn't work because we didn't have the parts from Marble Run. So what I ended up building instead was this mechanism. It's just a tennis ball can strapped onto a board with rubber bands, and I found the midpoint of the board and put 2 nails to act as axles, 1 nail, 2 nail. And so the ball was supposed to go in here, but I found out that when I put it on the board it would tip over too much, so I just solved the problem by putting a board here. Now it's stable, and when the pulley comes it'll pull this down and the ball will fall out onto the seesaw. So when working, I wanted to make sure the seesaw by itself would work. So I tested it out and found out that this setup wouldn't work because when I dropped the ball here, the figurine would fly towards the pulley and the sand wheel. So I switched them here, and I also designed it so the axle is removable and I can change the fulcrum whenever I wanted to make further calculations. Another thing I discovered was the normal tennis ball I was using was a bit too light. So what I did, it didn't work out. So what I ended up doing was taking a completely new tennis ball, puncturing a hole in it, and using a syringe to fill it with water, and it pretty much doubled the mass. And now when I drop it, it works much better. Alright, I'm outside of my yard, about to do the final project, run it and try to get my final measurements. So just to explain, this is the water wheel. I'm using a hose to push it, and then that spins a rope, and the rope is connected to a pulley down there, and the pulley connects up here to the tennis can, and when it pulls down, a tennis ball inside the can will fall down on the seesaw, which will catapult the guy forward onto the measuring tape. 3, 2, 1. Awesome. Alright. Good job. I finished my initial trial with the water-powered seesaw catapult mechanism, and I also made additional measurements and calculations by adjusting the fulcrum of the seesaw and changing the height of the work table to vary the drop height. And I used projectile motion equations, free fall equations, as well as conservation